Okay, so here we go. I am going to try to make it all the way to the end of the notes in this one. And recording 3 hours of myself talking in one day is kind of making me like, crazy. So, I apologize if I can't talk or seem like a crazy person today. Also, I apologize that I'm just gonna look like this for filming. I just realized that I didn't put any makeup on today or do my hair, and this is definitely not my pajamas. All right, so here's what we're gonna do. We're gonna start here, share, with did we cause climate change? Okay. So this is like a deep topic. And to be fair, I have been addressing this the whole time with the things I hear people say when I say climate change is important. Because there are natural fluctuations in our ecosystem, in solar output, and in the Earth's like eccentricity of its orbit and axial tilt and axial wobble and all these other things, right? And they all contribute to climate change. So where is the linchpin that is holding together the argument that we are doing this and we should maybe stop, right? And that starts on slide 59. So that's where I am, and that's where hopefully we're going to get into the nitty gritty. Okay. So we think, right, because we know that CO2 is such a good greenhouse gas, that we are contributing to climate change because we've seen the level of CO2 go up. But some people will say, what if it's just doing that on its own? Okay, so pause. There are more than one type of carbon. Okay, and so it has to do with the isotope. So we're calling back a little bit to your chemistry knowledge from your chemistry class, okay? And carbon-12 is the only type of carbon that plants use for photosynthesis. That means that the carbon-12 has 6 protons, 6 neutrons, and it is what plants use. Okay. There are other isotopes that are much less common, carbon-13 and carbon-14. Now, if you change the number of protons, you change what element it is. And that would be impressive because that requires a nuclear reaction, right? But changing the number of neutrons changes basically the weight, the heaviness of that particular atom, but it doesn't change the type of atom it is. And because atoms like to be balanced, right, their protons and electrons would hopefully be matched to make the atom neutral, right? You're not changing that quality of the atom by adding neutrons. You're just increasing the heaviness. Now, plants only use carbon-12. And fossil fuels are made of plants. Okay. Pin, right? Because when I was a child, used to believe that fossil fuels were made of dead dinosaurs. And that just is not the case. So let's think about it from like our ecosystem perspective. We know that 90% of energy is lost between trophic levels, right? 90% of the energy from grass is just lost in herbivores by them putting off body heat and jumping around and doing things, right? Okay. So that also translates to a 90% loss in mass between trophic levels. Okay, so what you're looking at is the fact that there is always, if you weighed all the plants in the world, going to be 90% more of them than if you weighed all the herbivores. Does that make sense? Like there is at least a 90% drop off, 10% of the mass, okay? And so realistically, there would not be very much oil or coal or natural gas if it was made of dinosaurs, because dinosaurs were herbivores, omnivores, or apex predators, all of which are higher up the trophic level, and there just wouldn't be that many of them, right? Because there wouldn't be enough herbivory, right, plants to sustain it, okay? So coal, oil, natural gas, made of dead plants, okay, dead plants, which means it is made of carbon-12, not carbon-13 or carbon-14. And we can see in the proxies, the ice samples, where we're dissolving them and we're looking at the percentages of the gases that are in there, that there has been an increase in the ratio of carbon-12 to carbon-13. That means there is more of plant-based carbon in the atmosphere than there is of miscellaneous carbon, right? And when you look at things like volcanoes, that's miscellaneous carbon. That would hypothetically erupt. It would still be mostly carbon-12, but it would have the other elements represented more highly because the volcano didn't breathe the carbon out. It exploded pieces of rock out. Does that make sense? Like, it's from a different source that didn't have to be alive. Nothing had to be alive for a volcano to happen. Things have to be alive for coal to happen. Okay, there had to have been plant matter that had to be subjected to a tremendous amount of heat and pressure over like millions of years, and it is made of carbon-12. Okay, so we can see that. We can see that the type of carbon that is in the ice proxies that we have taken since the Industrial Revolution is shifting towards more carbon-12, less carbon-13 than the carbon dioxide we see in the ice samples that are from before people started burning massive amounts of fossil fuels. Okay, cool, awesome. Also, there is a near unanimous consensus that climate change is occurring and that humans are at least partially responsible for it. Okay, so there's a list of associated scientific organizations that endorse this opinion. But I want you to think about the movie we watched first semester. It was an episode of Cosmos, and it was about lead in gasoline. Okay, cool. Lead in gasoline. And everyone was like, yeah, tetraethyl lead is a thing that goes in gasoline and it's fine, right? And then there was the guy whose name I cannot remember because I'm a bad science teacher, who was like, no, like I cannot get any samples of anything that is not contaminated with lead. It is coating every surface, and we know that lead is a neurotoxin, and why are we all just okay with this, right? And let's be clear, in science, when somebody comes up with a theory or a hypothesis that something is happening, it is the job of every single one of their peers to be like, you know that meme where it's like a little X button and it says doubt, right? That is what the science community does. Somebody says, I think this is happening. Everyone was like, well, you're probably wrong. And I'm going to check all your math and I'm going to try to prove you wrong actively. Okay. And so we look at that institutional doubt in the scientific community. And then we look at the fact that 97% of people have accepted not the null hypothesis. The null hypothesis would be the earth is just like this, right? 97% of scientists were convinced. And then I want you to think about the other thing, right? The other part of that video. In the congressional hearings for whether or not tetraethyl lead should be banned as an additive in gasoline, there were people who could be paid to disagree. And that is still the case, okay? There are still people who can be paid to disagree. When you look at the wild majority of people who think that climate change is real, they have charts and graphs and data. And a lot of the people who disagree a lot of the scientists actually don't disagree. They just go, maybe it's something else. And let me talk about that for a minute, because this is something that personally happened to me. One of my coworkers came up to me and was like, I found this article and it's like, climate change is definitely like caused by the sun changing temperature. And I was like, I'll try anything once, give me the article, right? So I found the article, which was paid for by like a conservative think tank that's trying to influence tax policy to favor fossil fuels. So I was like, okay. So when I Googled the scientist, I found his article, and I found that same think tank had published it with a foreword, right? And I read the foreword and it was like, this guy unequivocally says that climate change is caused by the sun. And I was like, oh no, right? Okay, so then I read his article, his 97-page article with over 115 sources. It took me weeks Okay, because I read it and I highlighted it and I annotated it, and every time he said something I went and I googled it and I looked at his sources and I looked at his citations and I made sure, and his conclusion was that maybe the sun is playing a bigger role than we think in climate change, and it was a proposal to do more research into that area. He did not say that anthropomorphic climate change is not real. Okay, he didn't say that. But the think tank purchased his article. They bought the rights to it and they added a foreword that said, this guy says it's not CO2, this guy says it's the sun. But when you read his article, that is not the argument he's making, right? And in his article, he had like 2 or 3 proposed mechanics of how solar intensity could be increasing. And he was like, but I'm not sure. I need more research money. That was his argument, right? Which, to be fair, I'm on his side. If that is the case, we need to be researching that. Right? But it was perverted by people who had a vested interest in the status quo. And so I would argue that a lot of the people who are in that 3%, they might not be making a bad faith argument, but some people are taking their research and using it to make a bad faith argument. Okay, so let's look at how biomes change as a result of climate change. Okay, so this is an aquatic ecosystem. It is specifically Indiana, and it is on slide 61. So first things first, if you are changing the climate, you are going to change the wind and water interaction around coastlines and further inland, so you are going to change the weather patterns. This is going to lead to a change in the amount of water, whether it increases or decreases, and the temperature of that water. It will usually get warmer. But like, again, we talked about the Gulf Stream and the exception with the ice flow off of the Greenland ice sheet, right? Also, the percent of the time that that ecosystem is frozen. Some places that is supposed to be 0. Sometimes, like I talked about with my lavender plant earlier, the plant requires to be frozen for a while in order to properly sprout, okay? Whether or not the system has time to dry and absorb water before more water comes, right? So if it is all of a sudden raining way more than usual, you are going to get massive erosion, landslides, loss of topsoil. If, on the other hand, you have plants with relatively shallow root systems because they're used to a constant supply of rain, and then you interrupt that supply of rain, you are looking at massive plant death, which can also cause erosion, but from wind, right? There's no longer a root system holding the topsoil in place. As a result, that sediment usually washes into the local rivers and streams, which increases the turbidity and sedimentation, meaning that a lot of creeks and rivers and ponds that used to have rocky bottoms now have sediment bottoms, which completely changes the plants and animals that can live there and use it as a habitat. Also, straight up, sometimes humans put stuff in the water that should not be in the water, right? Chemical runoff, oil running off of roadways, rubber running off of roadways. Also, the amount of water that can dissolve into, or the amount of oxygen that can dissolve into water that is highly turbid, like it has a high turbidity, it is full of sediment, is low. Remember how we look at that sewage pipe diagram where it shows the oxygen sag as the sewage exits the pipe and then it slowly recovers to where you can actually have, like, higher up the food chain, a more complex food chain? That's a big change, right? And so that's demonstrated here on this slide, showing how the warming waters, the stream changing, and the drying all potentially can lower the species richness, meaning there are fewer types of species, and lower the species density, which means that the number of each species will decrease over time, which can lead to ecosystem instability. Also, sea levels change the photic zone. Okay, so as more of the coastline is eroded, you are changing this distribution. So usually most things live in the photic zone, right? Because that is where photosynthesis can happen. And you can't have higher levels of the food chain if there isn't something turning sunlight into food at the bottom, okay? And so as a result, with the exception of geothermal vents, you are looking at sunlight. Well, what happens when that water is clouded? what happens when that water experiences an algae bloom that effectively blocks out the sun, right? What happens when storms are bringing very turbid, very polluted water to the surface as it flows off the continent when the rain stops, right? You could see the pollution in the water. Now, some of it was dirt, some of it was oil, some of it was silt, right? From Houston after Hurricane Harvey hitting the Gulf of Mexico. You could see that pollution from space because that water was no longer clear runoff. It was taking the topsoil with it. It was taking stuff off the roadways. It was taking a chunk of your neighbor's house with it. It was taking all these things with it that didn't belong there. And that had a serious impact on the photic zone of the ocean in the Galveston/Gulf of Mexico area. We've also talked about how the massive agricultural runoff that is rich in nitrogen and phosphorus causes algae blooms and massive fish kills in the Gulf of Mexico so many times that I feel like it should be a meme in my class. Also, global wind patterns are changing. So we've talked about these cells before when we talked about the atmosphere, but the wind usually blows in a particular direction, right? So it rises at the equator, that's what you're looking at in the Hadley cell, right? And then as it flows towards the poles, it cools and sinks, right? Then there are Ferrel cells, which are up in like the United States, Europe, Russia area, right? And they're doing the same thing in reverse, right? They are bringing cooler air from the poles south. And those two are distinct because it's really hard to mix really cold air and really warm air. And then finally, you look at your polar cells, right? And those are pretty isolated because they are so much colder than everything else. And those are driven largely by ocean currents and the Earth's rotation. And so when you alter the ocean currents, you are also altering the air that travels because of those currents. That's what we're seeing in the transition from La Nina to El Nino. Okay. Also, right, coming back to this brine phenomenon, right? As there is more cold water flowing off of the Greenland ice sheet, you are also going to see that warm water pooling in the Atlantic Ocean, which is problematic, right? If that warm air is no longer going north and then cooling off, and it is just pooling in the Atlantic Ocean, it is again unsurprising that we would see an increase in the severity and number of hurricanes. Okay. Also, we've talked about like 6 positive feedback loops here, and I need you to know that they're not separate. They stack on top of each other. Okay. So humans burn fossil fuels, and that increases the atmospheric carbon. Okay, that causes a rise in temperature. That rise in temperature will melt the polar ice caps, which will increase the volume in the oceans. And because it is warmer, more evaporation will happen, which will lead to more precipitation. So that's one positive feedback loop. Also, as there's a rise in air temperature, the land under Greenland and Antarctica starts to defrost. You're losing that permafrost. And so as a result, you get the carbon exhaled from that soil, like we talked about in the second video. Okay. Also, both of those things, the decreasing ice and the increasing brown soil, both change the albedo of the planet, which makes it more likely to absorb heat and less likely to reflect it back into space, which makes the problem of heating up worse, right? And as it heats up, now that you not only have all of that ice flow into the oceans, you also have the thermal expansion of that water, which is leading to rise in sea level, right? Now, that rise in sea level and that increase in temperature together work to make more severe weather patterns. And those severe weather patterns are more likely to erode off the coast soil and again raise the sea level. Okay, and so what I want you to know is that these things are connected. And I would, if I were you, I know that there's a cute little graphic on this slide 65, make your own. Go through this PowerPoint, okay, and Make your own feedback loop, because these are all independent variables that we have learned about in other parts of this course. That's why I call Unit 9 kind of a review. It's like, hey, let's review all the concepts and see how they come together. And synthesis questions are the College Board's bread and butter. Okay, so that's what you're looking at in those. Whee! All right, so there are two types of solutions. So I know that these videos have been pretty doom and gloom up until here, and hashtag sad face, right? There's mitigation and there's adaptation, and they are exactly what they sound like. So mitigation means try to stop it, and adaptation means this is going to change, and we need to be ready for it. And to be fair, I think that both have their merits and should probably be used together, right? So let's talk about some examples. Mitigation would be something like using the ocean and forest and soil as a carbon sink. Hi, Trent. Oh gosh, okay. Well, that's fine. Whee! How do I stop sharing my screen? And also stop recording?